Friends, I will talk about collection data and advantage of collection data, and finally we have a video about this subject. A database is a set of data that has a regular structure and that is organized in such a way that a computer can easily find the desired information. Data is collection of distant piece of information, particularly information that has been formatted in some specific way for use in analysis or making decision. A database can generally be looked at as being a collection of records, each of which contains one or more facts about some entity, such as a person, organization, city, product, work, of art, recipe, chemical, or sequence of DNA. For example, the files for a database that is about people who work for a specific company might include the name, telephone number, date employed started, position, and salary for each worker. Several basic types of database models have been developed, including Sachs model desired not only the structure of the conforming database, but also the operations that can be performed on them. Typically, a database has a schema, which is a description of the model, include the types of entities that are in it and the relationship among them. Flat databases are the simplest type. They were long the domination type, and they can still be useful, particularly for example small scale and simple application. An example is a single table on paper or in a computer file that contains a list of combinations with information about each such as name, addresses, product category, contact name, etc. A flat database can also exist in the form of a set of index cards, each containing the information for one of the entities. The development and subjective repeat advantage of electronic computers in the second half of the 20th century led of the development of database models that are far more efficient for dealing with large volumes of information than flat database. The most notable is a relational model, which was proposed by a called a researcher at IBM, created existing data models for their inability to distinguish between the observed description of data structure and description of the physically accessed machines. A relational database is a way of organizing data such that it appears to the user to be stored in a series of interesting tables interested in the model. While interest confined to academia purpose because the theoretical basic is not easy to understand, and thus the first commercial products, Oracle and DB2, did not operate until around subsequent relation database become the domination type for high performance applications because of their efficiency, ease of use, and ability to perform a variety of useful tasks that had not been originally environment. Hypermedia can be considered to be a type of network database. Hypermedia is a computer-based information retrieval system that enables users to gain or provide access to text, images, and sound via hyperlinks. Most hypermedia consist of hypertext, and the largest example by far is of course the web. Advantage. Here advantage of using a database are considerable. Without them you would be hard pressed to find a decent system of keeping and managing information. In recent years, the inherent flexibility and user friendliness of database make these systems a crucial business component. Many database solutions are available for any type of business need, ranging for storing consumer information metrics to hosting a WordPress blog. Here are the top reasons for using a database. Database save time. Instead of running through an endless piles of paperwork, a database pulls up information with simple query. A user can enter in specific keywords in order to recall information. The database becomes a more efficient solution than paper files held in a file folder. Database aid communication. Larger companies can benefit from databases when information must be spread a various users. For example, if a company has two branches but must share central information, it would be prudent to implement a central database that can be viewed by all employees of that company. This way, once information added, it is viewable by all, aiding in a chooses work environment. By looking at database records and how that has changed over time, you can also track important trends such as which product is most popular with your customer, which can make your business more complete. Databases are more secure. File cabinets can be compressed, they can be stolen, accidentally destroyed, or lost. Database and another level of security to viable information. Not only can a database be stored in a remote fallacy environment by various events such as fire or terror, but a database can also be password product. Database are managers. Some smaller businesses are always looking for ways to cut costs without cutting quality. A database can be a hefty investment entirely, but over the long term, it will save money by improving the efficiency of our employees, impress customers who will not need to repeat their information, and saving on paper cost. Now we will see a video about collecting data. I hope it will be useful for you.
Hi there. In this tutorial, we're going to give a brief overview of exactly what a database is. Now, a database, more than anything, is a collection of tables, and a table is nothing more than a collection of information that you'd like to manage. So we're going to give this entire discussion in the context of a sample movies database that we've provided with QuerySmith. And the data for that database comes from a website called themoviedb.org. Now that website has a very extensive list of popular movies and the actors that were in the movies, a collection of image information and trailer information as well. So we've copied a bunch of that information into a sample database that you can query, and we're thinking that it'll be easy for people to learn what a database is by having a look at what your favorite movies and your favorite actors are. So we're going to show you how you can poke around a new database using QuerySmith to learn what's in it, learn the structure of it, and different things like that. So we're going to talk about that as well. So we should begin by talking about exactly what a table is. If you look at this Excel worksheet here, what we have is a collection of movies. Now each row in this worksheet that we're looking at has the identical structure. So on the left hand side we've got a unique movie ID that we've assigned to each movie. Now if we've got two movies that happen to have the same name, we can tell them apart because they've got this unique movie ID number. We've recorded the name of the movie as well. We've recorded what language the movie was filmed in. We've got a rating value from 1 to 10. We've got the release date of the film if it happens to be known. We've got the runtime length in minutes of the film, and we've got the budget and revenue figures for the film as well. So a table is nothing more than a collection of rows that each have the identical column structure. So basically anything that we have an interest in managing, we have thousands and thousands of movies we want to record. Every movie row within our movie table happens to have the same structure, and that structure allows us to have very extensive query capabilities and searching and sorting capabilities that we'll be able to take advantage of when we want to go looking for specific movie information. So this table structure here of movies is one table that we're interested in managing. But if I flip over and I can have a look at a second worksheet, I have a second worksheet that contains a list of people that work in this movie. Now, that may be that they are actors in films, but it also includes information for producers and directors and costume designers and lighting personnel and sound editors and things like that. So anybody who's associated with working on a film is recorded in this people table. So what I'm going to do now is just have a look at the relationships that might exist between pieces of information in a database that we're interested in. We've talked about two tables so far. We've talked about a movies table, and we've had a quick look at the information that was recorded in there. We also had a look at a people table, and this is the list of people that work in the movies. And then what we've got is a table that associates the people that worked in a given movie. If we take an example, for example, Julia Roberts, we all know that Julia Roberts is a very famous actress, and she's worked in a variety of different movies, and so we're going to be able to have an association between what movies she was in this movie people table. And again, if you take a look at a movie that she was in, something like Ocean's 11, for example, that's a movie that had a number of actors, and so for each actor in that movie, we'll see a record in this movie people table. So a database is a collection of all these different lists, and the lists have relations with one another so that you can tie the information together. So we can also take this in another direction. For example, if we have a look over here, we know that every movie is produced by a movie studio, and we know that movie studios produce usually a wide number of films. So the studios exist of their own right, and then we've got a movie studios table that associates a movie and a studio together. Same thing with countries. Every movie's filmed in one or more countries, so we've got a list of the countries in the world, and we've got a list of what countries a particular movie happened to be filmed in. We've got a list of categories that a movie can be classified in, and this could be drama or comedy or thriller or different things like that. And we know that a movie can have multiple classifications. You might have, for example, a comedy thriller. So that would just be an example of where we associate one movie with multiple categories. So a database is a collection of all these different lists of information that we want to manage, and it's a definition of the relationships that exist between the different lists that we want to manage. So let's now use QuerySmith to have a look at the movies database, and we'll see how we can poke around this database and learn a little bit more about its structure from using QuerySmith. So on the left-hand side, we've got the list of the tables and views in a database. We're only going to talk about tables for the time being. And as we select different tables in the left-hand list, all of the supporting windows on the bottom of the query editor will update, and they'll give you information about the table that you have selected. So if we look at our movies table, this is the table that we saw in Excel, we can see a description of the table name by looking in the table comments section. We can see a explanation about each of the columns that exists in the table. We can learn the column names. We can learn a little bit about the comment information or the description about what it is that that column does. We've got the data type that that column contains, its position within the table, and also an indicator for whether or not the column is required in the table. So if we were to insert a new row, we've got a flag indicating whether or not a value has to be in the column or not, and that becomes significant when we're searching for data later on. We'll defer the discussion of that for a brief amount of time, and we'll cover that in a later tutorial. We've also got a sample data tab that we can flip to, and you'll see information that's very similar to what we saw in the Excel sheet, but you'll also see a number of columns that were excluded from the Excel worksheet, and we'll talk about why. So we can see the movie ID again. We can see what type it is, whether it's a movie or a movie series. We've got the name. We've got an alternative name. You know, if the movie was originally either in English and translated to another language, or if it was originally filmed in something other than English but has an English name, we can see both of that recorded here. We've also got an overview of the movie. Now this is quite lengthy information, which is why it was excluded from the Excel worksheet that we studied, but we can see that we've got that information is available to be queried, and we can see some sample data for that. Scrolling over to the right, we've got a home page recorded for the movie if you want to go on the web and browse that movie information produced by the studio. We've got a number of YouTube trailers for the films that we've got here. Continuing over to the right hand side here, we've got the certification for what the movie is, whether it's an R-rated movie, maybe PG-13. We've got the rating from 1 to 10, the release date. So anyway, we've got all of this different information that we can have a look at in order to gain an understanding of what's in our database, and as we look at different tables on the left hand side, we'll see that the information in the sample data tab is updated. So we've talked a little bit about how all of the different tables or lists we've got on the left hand side are related to one another. From our diagram that we were looking at before, we can remember that a movie is categorized according to various different things like a drama or a thriller or a comedy. We can remember that it's filmed in one or more countries. We can remember that it's got one or more actors and directors and producers associated with it. And it's one or more movie studios that is associated with having created that movie. So the relationships browser within QuerySmith will help you gain a bit of an understanding of what the structure is of that database as you're looking to learn it. So that's actually where we're going to stop the discussion for the time being of what the database is. That basically concludes the tutorial on what a database is, so you can learn a little bit about your database using QuerySmith. And that's it. I want to thank you very much for watching. My name is Brian Hawes. I'm a developer with Powder Software. Have a great day.